So in this injection method, we have got port injection and direct injection. The first one is a port injection. As the name suggests, the injection of fuel which is taken in the port. So you can see in this figure that this piston, cylinder, fuel injector, spark plug. This is the throttle valve. So, so when the suction stroke happens, that means when piston moves from TDC to PDC, right? So this intake valve will be open. Even before the intake valve is open, the fuel will be injected in the inlet port. So, and the piston then thereafter, the piston will be in the suction stroke. The piston will be moving from TDC to BDC, and intake valve will open. That time, air and the fuel which was injected just before will mix with the fresh air, and that will be coming inside the combustion chamber. And then thereafter, there's a compression stroke occurs. Then compression stroke, then the fuel will burn with the help of the spark plug will be producing the spark, and fuel will be burned. Explosion will happen in the combustion chamber, and the piston will be moving downwards to the BDC, then exhaust stroke, and the cycle goes on. So here in port injection, what we did is that we have placed a fuel injector just before the intake valve. So this fuel, actually it is in liquid form. So this liquid fuel, when it is even in its a liquid form, it is very atomized small droplets. So that liquid atomized small droplets will evaporate and convert into gaseous state. To do that, I mean to convert that liquid state to vapor state, it takes energy from the surrounding oxygen molecules. So the surrounding oxygen molecules or air molecules will get cooled down. So when it's cooled down, the density of air is reduced. That means density of the air is getting increased. That means the air is get more dense because it has cooled down. So that air has got more number of oxygen molecules, and that air, that means the higher cool, fresh, dense air will be coming inside the combustion chamber when the intake valve is opening. So that is a good advantage of using port injection method. So it draw more amount of air because it's dense, highly dense. So more amount of oxygen molecules will be there. So if we can introduce more amount of air, we can produce more power by introducing more fuel. So we introduce little more fuel because it can all these can be burned inside the combustion chamber, and we can produce more power. So that is one advantage of port injection. And also it produces a cooling effect. As I said, this cooling effect makes it makes it to increase the density. And another advantage of having a fuel injector over here in port injection, in case of direct injection, the injector is placed directly above on cylinder head, so directly above the combustion chamber there itself. So in port injection, as I told before, this injector is injecting the fuel even before the intake valve opens, before the suction stroke, before the intake valve opens. So this fuel is injected even before the intake valve opens. So the air is already there. So air and fuel mixture will happen from here itself. From here itself, we can form an air fuel mixture, and that air fuel mixture is again coming into the combustion chamber in suction stroke. So it again gets more time to make a proper mixture. And in the compression stroke, when the piston goes from TDC to BDC, there also the mixture is happening. So ideally, means ultimately what is happening, the air fuel mixture is getting more time to form a proper mixture, which is not possible in case of direct injection. So in case of direct injection, the injector is in the combustion chamber. So if we get only time for proper mixture when the air and fuel is inside the combustion chamber. Here, even before the air and fuel coming into the combustion chamber, there is a proper mixing happening. So that is also advantage of port injection. So let's come to the other one, direct injection. So initially, the first time actually the port injection was used, then the new invention has come, direct injection. In direct injection, we are using the fuel injector exactly above the combustion chamber on the cylinder head. So as like normal suction stroke, the intake valve will be opening and air fuel mixture will be coming inside. Okay, and when not fuel mixture, only air will be coming inside, and according to the air, whatever the temperature and the density of the air, according to that, it will give signal. Actually, there are sensors to identify all these things. So the sensors will identify the nature of the oxygen, and according to that, it will give signal to the fuel injector to give exactly correct amount of fuel to burn inside the combustion chamber. So why we have switched to direct injection? The first thing why we have switched to direct injection is that, as I mentioned before, when we inject the fuel, that will be in liquid form. So this liquid form will evaporate and form a gaseous state, right? So when this transformation happens, that time it cools down the surrounding air. So it's cool down the surrounding air means it makes the air more dense, and also it cools the whole process, or the inside the combustion chamber it is getting cooled. That will reduce the knocking. So knocking is one of major disadvantage in engine. So if we can reduce that probability or the chance of knocking in engine, that will be a great advantage. And that is the reason why direct injection has been implemented in the first place. And another advantage of direct injection is that it can use different time of injection. That means here, in case of pot injection, we have to introduce the fuel before the opening of the intake valve. But here we don't have such limitation. Even you can inject the fuel at the compression stroke or even the suction stroke. That is according to how much we wanted to make. Mixture of air fuel. So there is no limitation for that. We could introduce whenever we wanted. So that is one advantage. Then in this direct injection, we are introducing the fuel, or the injector is exactly in the combustion chamber. So this injector should be capable to withstand that pressure. It should be high pressure fuel injector. And another one, reduce the chance of knock, as I said. So when we reduce the chance of knock, means if we can reduce the chance of knock, we can definitely increase the compression ratio. When we increase the compression ratio, we can produce more power. So here also in direct injection also we are producing more power than the conventional engines. So in pot injection also we can produce more power. So both are actually very good design, but direct injection has got an upper hand because it can reduce the knock. And so when we reduce the knock, we can increase the compression ratio and increase the power. So that's where direct injection has got an upper hand. But nowadays it's pot injections and direct injections are combined and using. So pot injection plus direct injection engines are used. In that kind of engines, here there will be one more fuel injector. Okay, so it's same like this thing. So we can decide, that is up to the scenario, like when we wanted to use the fuel injector, pot fuel injector, when we wanted to use the direct fuel injector. In some engines we use both, and simultaneously in some engines it's as per the requirement. For example, normally in case of for example, if this is a torque, this is speed or RPM. For around normal smaller torque and smaller speed RPM, that time we use pot injection. Okay, and when the torque is around medium, that time we use pot injection plus direct injection. And when the torque is higher, speed is higher, that time we use only direct injection. Because the reason is that initially we can use the pot injection because it can draw more amount of air. This direct injection can there we are not getting the advantage of drawing more amount of air. Only in pot injection we are getting that advantage. So in slow RPMs we don't have any we don't have any problem of knocking, so there is nothing to worry about that thing. So in slow RPM we could go straight forward for using this pot injection. So pot injection will be used which have the advantage of drawing more air. So that will be used in initial condition of smaller torque and smaller RPM. And when it comes to medium RPM, that time both the port injection as well as this direct injection is used. In some engines only port injection will be used. That also depends upon the company how they are choosing which way they want it. And when it goes to higher torque, that time it will be using only direct injection, because there when the RPM increases, that time the probability of knocking is more. So we don't want to make a chance. So we will be avoiding the usage of port injector. So only direct injection will be used. So the advantages, that is the reason why we are using port plus direct injection, because here we're getting the advantage of port injection as well as the direct injection, and making it much more efficient, much more perfect. Okay, and another big advantage of port injection, which I have actually forgot to mention, that here we have got a fuel injector. So when the fuel injector injects the fuel, it's actually clean this inlet port. So when the inlet port, so in port injection engines, all the inlet valves are clean. So otherwise there will be debris or like carbon deposits in normal cases. So port injection is also used when we wanted to avoid this choking, or to avoid the dirty intake valve. So you may be thinking like how this intake valve is getting dirty. Sometime when combustion takes place, sometimes blow-by happens. Blow-by means if some amount of combusted products or flue gas, or what you say, like burned gases, will escape through the gap between the piston and the cylinder. Even the piston rings are not holding enough, so some gases got leaked, and that will be coming inside the crankcase, right? So the crankcase will be filled with oil, and it will be splashing every time, and when engine is running, that time the oil will be splashing and oil mist will be formed inside the crankcase. So here we have got we have to pass this air, because it will pressurize yours, right? So we have to keep a breather, or we should have a positive crankcase ventilation here. That means whatever the air that comes in the crankcase, it will be fed back to the intake port. So we have a mechanism for that. And the oil, or the gas which is going back to the intake port is actually it contains oil mist, so, and some burned gases that will be coming back to the intake port, and when it hits on this intake valves, it sticks on top of it and makes it dirty. That is one reason. Another reason, if modern engines, we use exhaust gas recirculation. So the exhaust gas which is used, it will be recirculated and fed back into the intake port. Exhaust gas recirculation. This is actually used in order to avoid the emission for emission control. That's why it's used. So there also you can find certain burn particles or carbon particles. So all these things makes this intake port very much dirty. So if you place a fuel injector over here, and the fuel injects, it's actually washes away all the carbon particles which sticks on top of the intake valve. So you will find that all the port injection engines or port plus direct injection engines intake valves are much cleaner. And also we should also know that this direct injection engines, not a port plus direct, just direct injection engines, having a problem of carbon deposit on intake valves. So maybe that may be the reason maybe port plus direct injection is using, because there are many other reasons, as I have explained before, and that also a relevant reason. So that's all about port injection and port plus direct injection and direct injection. So I hope you understood the video. If you like the video, please click the like button and subscribe. Thank you.